Welcome engineers, Hassan here. Today we are talking about binary. In day-to-day life, we usually use decimal system, which is represented by numbers like 1, 2, 3. Any number can be constructed out of digits from 0 to 9. Combining them, we get double-digit numbers. We can combine as many as we like, and by doing so, we can express different metrics or even meanings. Binary consists of only zeros and ones. Each digit is called bit because, well, binary digit. Bit. Although array of digits available to us is much shorter compared to decimal, we can still combine them and all the regular rules and qualities of a decimal apply. In case you are not familiar with binary yet, I encourage you to write down first 20 or so numbers in binary so you can get used to them. Because really, it's not any different from decimal. 0 is still 0, 1 is a 1, but next number requires you to go double digits, so you get 1, 0. Continue this process and you will see how quickly this becomes intuitive. Let's say you have a binary number and you want to convert it to decimal. One way of thinking about it is to match each binary digit to an exponent of 2, going from right to left, from least significant digit to the most significant one. Each bit represents an increasing power of 2. Each time you see a 1 at an index I, you may write down 2 to the power of I. The sum of these exponents is the number we are looking for. Here are our exponents, and these are the digits of our binary number. Converted to simple form, remove all the digits with 0 multiplier, calculate the sum, and you have just converted a binary to decimal. Let's do the opposite. One way of converting a decimal into a binary is by writing it as a sum of power of 2. Then, convert it to an exponent form. The exponents will tell us at which indices are we going to have ones, while the rest indices will contain zeros. One more time. Each exponent corresponds to a 1. We go from right to left by writing 1 at every index we have corresponding exponent. In this example, we start at index 0. Then we write a digit 0 at every position to the left until we reach the next exponent, in this example at position 2. And just like that, you have converted decimal to binary. Binary can also represent any other metric as long as we can write it with numbers. Boolean is the most obvious example. We express true as 1 and false as 0. We can also express characters. For example, ASCII code for a character A is represented as number 65, B as 66, and so on. Combining these numbers together, we can express text. Colors are often represented as an RGB triplet, where each number is between 0 and 255. By combining them together, you can get practically any color you want. Often you will see it encoded in hexadecimal, but you can also encode it in binary just as easily. Usually, binary numbers are stored in memory in groups of 8, 16, 32, or 64. The last one being the most common. Most programming languages have data types of various sizes for these representations. In Java, that would be byte, short, int, and long. And that's been a quick overview of binary. If you have any questions or comments, please leave them down below. Thank you for watching.